Welcome to the final exam, question number 35. It says the ratio of the unit stress to unit strain for a material is a measure of its blank, and it gives you A, B, C, and D. And A is strength, which we know is not correct. Stress over strain for a material is this measure of its B, stiffness. And the only other, toughness, no. Ductility, possibly. Going through my mind, I'm going, what would I say on a test? I would say possibly the best answer is definitely stiffness. Because, remember, this is stress. I'm going to put stress like that. Strain, I'm going to do like that. And then it goes up like so, and that's the... And then it curves off, and then it'll go up. That's strain hardening. This is for steel. This is called strain hardening when it goes from there to there. And I would say between stiffness and, I'm going to cross this out, but ductility. Hopefully strength and toughness aren't oh, that's not ductility. Ductility is actually C. But hopefully you know by now it's not strength, because the ratio of unit stress to unit strain for material is E, and it's stress over strain. That's actually what we're talking about. We're talking about modulus of elasticity. Oops. And in this before it starts to curve over, that's called your plastic, or elastic, sorry. Elastic zone, and this is your plastic. From here over is your plastic. And we typically would like to design in the elastic. You can do plastic design, but elastic design is what is simple. It makes sense. It's obvious because you're not going to want something to do any strain. If you ever stress something in the elastic region, it will go up. That's not a good color. Let's try pink. You'll be able to see that. It will go up, and then when you, for this, let's say you stress it this much right here, when you, it will actually strain this much. But as soon as you let that stress off, it will actually go back down to here. It'll go back down to zero strain. But once you get to a point where you are out of the elastic region, once it's that curve starts to come over, it'll come over here, and let's say you stress it to this point. So you just a little bit more, but that put over the yield stress, and now you stressed it to right there. Okay, so now it's strained a little bit. It's elongated, and then you let go of that stress. What's going to happen is it's going to follow that same ratio down, and then the permanent strain or elongation is going to be strain times your. It is going to be that. It is going to be your permanent deformation. I hope that makes sense, because close enough. I forgot an A. That's permanent deformation. So this distance right here is your permanent deformation, and it's always going to do that. For instance, if you stress it all the way to up here, right before it breaks, it fails, then when you unstress it, it's going to follow that same ratio down, and this is going to be your permanent deformation. All right, I think I beat that like a dead horse. I guess ductility. I want to explain ductility. Stiffness is how, and I understand how that's this is something you just have to remember. It's how stiff that material is, that ratio. And then ductility is kind of the can you pull it? You know, malleability is more. When I think of malleability, is when somebody's hitting something with a hammer. I always think of making a steel, a sword. Well, you know, the blacksmiths are hitting that, and they're smashing that together, and it's malleable, it's moving. in the smashing. It's more compression. Ductility, I always think, is when you're pulling something apart and you're trying to make that. Let's say you have not a pipe, but a circular bar into a string. And at what point does that break? And I always think of it more of this is like the ductile point, and I know that might not be 100% the scientific answer, but more when it hits its ultimate yield, where the plastic, its ultimate yield stress is, where that's how ductile it is. How far did this move out? How ductile is it? And that's, I know I'm using the the definition and the word in the definition. Sorry, but so without going any further, I look at ductility as this: how far can it stretch? How thin does that bar get? And when you're thinking how thin, it's also this thinning makes it how long. How long can that bar stretch before it breaks? And that's the ductility, as opposed to our question as what's the ratio of stress over strain? Is a measure of its what? And that's why I said stiffness is a much better answer. So once again, your answer is B, stiffness.